our last set of domain examples. The third one, hopefully you've been watching the first two. Domain restrictions off on the right again. The F is for, do we have x in the bottom of a fraction? Are we taking the even root of x? And does x have a negative exponent? Those are the three things we look for to determine if there's any number that x cannot be. So our first example, f of x, is the fourth root of 6 minus 2x. So first, is x in the bottom of a fraction? No, it's not. Are we taking an even root of x? So here's where it might get a little confusing. We are taking an even root, but if you notice, it's an even root of 6. The x is not actually in there with the even root. Actually, I think that's my typo. Let's just change this for a second, just so we can talk about it a little bit more. Let's take the fourth root of everything. Okay, so now we are taking the even root of x, because x is inside that radical. So when we take the even root of x, this whole thing has to be, it can't be negative. Whatever x is, when we plug it in, we can't get that negative number. So 6 minus 2x, to say that it can't be negative, we're going to say it has to be greater than or equal to 0. So we could maybe in our heads try to figure out what this number would be, or if it's easier, just kind of see it as an inequality like this, where we just can solve for x and see how now we're dividing by a negative number, which means we will flip our sign. So x has to be less than or equal to a 3. So we did have that even root, and now negative exponent, we don't have one of those. So our domain on this one is all real numbers, but x just has to be less than or equal to 3. Alright, g of x equals 2x to the negative 2 power. So we go through our restrictions. Is x in the bottom of a fraction? No. Are we taking an even root of x? No. Do we have a negative exponent with x? Yes, we do. So this is where we look and say, well, if we have a negative exponent, we actually have to do something with that. It's going to go to the bottom of a fraction. So we end up with 2 over x squared. So now it just backs us up a step to say, oh, now we do have x in the bottom of a fraction. So our entire denominator cannot equal 0. X squared cannot equal 0. So what can x not be in this case? X cannot be a 0. So domain is all real numbers, except x just cannot be a 0. That's the one number it can't be. Alright, last problem. H of x equals 4x to the 3/4. Go through our domain restrictions. Is x in the bottom of a fraction? No. Are we taking an even root of x? Now you might be quick to say no because we don't see a radical, but when we see that there's x to the 3/4, we want to look at that bottom number and say, is that an even number? Because remember, the bottom number up here is a root, and since it's the fourth root, we are taking an even root, and that tells us that what we're taking the even root of, which is just the x, has to be positive. So we're taking the even root of x. X has to be positive, which means it has to be greater than or equal to 0. So there's one restriction. And then last one, are we taking a negative exponent of x? We're not. So we just have that one restriction. Our domain will be all real numbers, but x has to be greater than or equal to 0. So be careful on those. You know, don't look for just the radical, because we can use a different notation and mean the same thing, where that is an even root right there.